Dr. Kaushal Kumar Jha. I welcome you, sir, once again to this session, and uh, I hand over this session to Dr. Kaushal Kumar Jha. So, please, sir.
Thank you, Mohan. Thank you very much.
Thank you, sir.
So,
Thank you.
before going to say anything, I'll just start my presentation. So you have to stop presenting. Yeah.
Yes, sir. Yes, sir. I'm doing it, sir. I'm doing it.
Yeah.
Yes, sir. Yes, sir. Done, sir. Done.
No problem. So just 1 minute. Hmm. So are you able to see my screen? Fundamentals of battery pack design.
Yes, sir. Yes, sir. Yes, sir.
Fine. That's good. Okay. I welcome you all of you in this particular session. So the total course, if I say, it's like a fundamentals of battery pack design. In that particularly, I'll be talking mechanical design today, and tomorrow I'll be talking about thermal design. So let's move ahead. So what does a battery pack needs? Why it is important to design a proper battery pack? So right side, there is a picture which says that car is under fire. It could be an ICE engine vehicle, it could be a hybrid, or it could be an electric vehicle. However, in hybrid and electric, there is no petrol or diesel, but there is another fire source known as battery. If it is mishandled, a situation like crash, or you are not taking care of proper design, what happens? This battery would blast like as a bomb. So, not to let that situation happen, we try to do a proper mechanical design so that even in such an adverse condition, which is generally a worst case condition, energy should not come out from the package or the box where the batteries are kept. So what I'm going to share with you today, how to do that. Before that, let's move ahead. What a battery pack need: a proper electrical design, a proper thermal design. Life is very important because the battery is costly. It's a capital cost. It's upfront cost. Not like diesel and petrol, which you buy need basis. You have to go 200 kilometers, you get filled some 20 liters of petrol or diesel. But here it's upfront cost. At the same time, when you are buying a vehicle, you have to buy the battery also. So that battery should give you sufficient number of charge and discharge cycle, sufficient number of years to operate, sufficient kilometers to operate, so that you can recover the cost. So life becomes very important. Then durability. You know, Indian road conditions, somewhere there would be a path hole, somewhere there would be water logging, there is extreme winter, there is extreme rain, there is extreme heat or summer days. In all those conditions, our battery pack should be working within the safe limits. Then the performance. The one important aspect of a battery pack is that it has to be as small as possible and should give us as much as energy possible. Then only it can substitute petrol or diesel. So a petrol vehicle or a diesel vehicle, or I can say IC engines vehicle, the energy efficiency is around 20%. However, the energy density is almost 20 times of the what the battery pack can provide today. But an electric vehicle is as efficient as up to 80%, 80, 85%. So the efficiency becomes 4 times higher in electric vehicle or hybrid. I don't talk about hybrid. Here I can say electric, pure electric vehicle. So efficiency is 4 times higher. However, the energy density is almost 10 times lower than petrol and diesel. So on an average basis, what you require, the 4 times bigger battery, 4 times of energy compared to what, I don't say energy, 4 times bigger pack than the petrol tank, you say, petrol tank or diesel tank, than what is available currently. So that means you have to worry about packaging issue, where to get that space. So if performance improves, you can utilize slightly lesser space and can get more energy. Now, in the case of hybrid vehicles, what is required is the high energy coming in as a charging during braking, and then high energy will, very high energy, you can say power. The high power would be required to boost up. In both cases, a battery, we have to design a battery which can give high power on demand and can take high power during the braking. So how efficient that is, how good performing, that becomes performance. Safety. Whatever the worst case scenario, it should not fail, either in cranking or overheating or loose connections or vibrations. It should be intact. It should not harm the occupant. Now, how do we generally go for battery pack development process? So battery can be divided into four parts. A design of a battery pack can be divided into 4 parts. The first one is mechanical design, then thermal management, then electrical design, and then the brain of the battery management system. Now, I'll go for each and everything in details. I'm just trying 2 things in detail, mechanical and thermal, but I'll just give you an introduction why these designs are required. So why mechanical design is required? To have a safe structure for extreme conditions. The extreme condition is even on the max speed or the rated gradient or a path hole or in accidental scenarios like crash, the structure should be sufficiently strong which can cover the cells inside that one. It should not allow the impact of a crash to be transmitted to the cells, because if that has gone to the cells, then cells will rupture, fire will take place, and all those problems will happen. What others are important? What are the other things of importance in mechanical design? It's a cost, as it is going to be upfront cost. It's a capital cost, so the cost has to be minimized. Productivity. Instead of a bigger battery pack, can I use a smaller battery pack and get the similar productivities. Then it comes reliability. How reliable? Will it give me what manufacturers or what a researcher is claiming? If they are claiming it can go up to 1,000 cycles, is it going? Or it's a condition based. If it is condition based, like temperature should be 25 degrees C, then only 1,000 cycles. Can we predict the average temperature of in whole year cycles and then the number of cycles it can go? Now, third one is ease of assembly and service. See, being a mechanical system, it will certainly fail time to time. If it is not accessible to service, then you have to remove the complete battery pack, then do the service and put it back. Even during the assembly, if the sequence are not proper, we'll end up using extra manpower and the extra resources. And this all things will add up to the cost and productivity. So the ease of assembly and service is one of the important criteria of mechanical design. And not the last, it should look beautiful, aesthetic. It should be compact because space is also in premium in mobility applications like car or two-wheeler or three-wheeler. So within the space, how can we pack the maximum energy? So that becomes compactness. And lightweight, if the weight keeps on increasing, what happens finally? It will impact the range. So the picture, what you see at the bottom, that a car is toppled. Why? Because there is a manhole. You can see here, there is a manhole here. So somehow one of the tire would have got stuck there and then this car got toppled. If this structure would not have been safe, this is what is the mechanical design or mechanical pack of a battery. If this structure would not have been safe, what would have happened? Cell would have got all this impact energy and then it would have disintegrated. There are several chemicals inside. Generally, those chemicals independently are not hazardous, but it can catch a fire. And that can lead to the burning of complete vehicle, including the occupant. So we'll move to the next, the thermal design. The importance of thermal design is that a cell, which is a primitive unit of a battery pack, works great during the certain temperature range. And that temperature range is around 15 degree to 35 degrees centigrade. However, in most part of the India, the temperature almost throughout the year would be either more than 45 or less than 15 degree. During the winter season, if you go to the states like Delhi, Rajasthan, UP, Bihar, Bengal, the temperature would be 45 plus during summer. And during the winter, the temperature would be 3 degree, 4 degree, 5 degree. Sometimes it goes even in minus. If you go towards Punjab, Himachal, Jammu and Kashmir, Leh and Ladakh, at those places. So what happens if the temperature is high or low? The cycle life, the number of charge and discharge cycle of the battery comes down drastically. What do I mean to say here? That if a cell which could have given a cycle life of 1000, that means it can be charged 1000 times and can be discharged at 1000 times. If the temperature is going beyond 35 degrees, let's suppose 45 degrees, the same cell can work only up to 200 cycles. That means 200 charge and 200 discharge. So what happened? The cell life has come down by 1/5. So is there any mean where by that we can maintain the cell temperature or the pack temperature? If you are able to maintain the pack temperature between 15 to 35, that would help us to recover the maximum cost out of the battery pack by increasing the number of charge and discharge cycles. The another problems what happens is thermal runaway or thermal accidents. If the temperature is not controlled, if temperature is not controlled, temperature will keep on rising. When that will happen, after a certain temperature, the chemical reactions inside the battery becomes uncontrollable, and it will come as a fire. Such incidents we say as a thermal accidents or thermal runaway. So a proper thermal management system, a proper thermal design is required to mitigate this type of thermal accidents. Third point I have already talked, increase cells and as well as pack life. Now, the first point was improve pack efficiency. The improved pack efficiency, what it means that at an elevated temperature, you cannot discharge at its full capacity, or you cannot even charge it at a full capacity. Why? Because that would further elevate the temperature. So you have to reduce your charging current or discharge current, and thus you're reducing the pack efficiency. Now, next is electrical design. In electrical design, why it is important? We find out what is the capacity, voltage, and current required to run the vehicle. And based upon that voltage, current, and capacity, we arrange the cells in series and parallel, or parallel in series, to deliver that particular capacity. You can see here. So there are several cells, 1, 2, 3, 4, similar way in this side, and these all are connected in series and parallel combination. And with this series and parallel combination, finally gives you the required capacity in kilowatt hour or watt hour, then required voltage and the required current. The other things what we need to look on in electrical design is high voltage isolation. So in India, anything below 120 volt DC, we say it's a low voltage. And then anything above 120, we say high voltage. So the low voltage and high voltage simple definition is a direct touch is generally not harmful generally in low voltage case. However, in high voltage case, it's harmful to the human. So whenever we are making a high voltage battery packs, so we need to have a high voltage isolation. That means if by any chance my battery terminal or the cables coming out from the battery has touched the car body or chassis, battery should automatically disconnect. So that's what we say high voltage isolation. The another scenario which can come in such type of situation is short circuit. If a positive and negative terminals of any wires, then what will happen? The high current will be drawn, and when high current would be drawn, what will happen? The battery will get heated up like anything, and then at the end of the day, it may trigger to the thermal accidents. If the short circuit scenario is for longer duration, the localized melting bus bars, of melting of bus bars, even melting of the cells can take place. The another important point which need to be looked upon in electrical design is efficient power delivery. So even the battery energy is limited, however, power can be multifold. You can drain the battery in half an hour, you can drain the battery in 1 hour, you can drain the battery in 10 minutes. Especially in hybrid application, you need to drain the battery very quickly, you need to charge the battery very quickly. So that means the current incoming to the battery and outgoing from the battery would be very high. And the simple thermal expression, the thermal output of such current is I square R, where R is the resistance of the path. So you increase the current, you are increasing the thermal load by I square, means the square of the term. If it is getting heated up very high, then you cannot draw further power. So the efficient power delivery mechanism also need to be ensured during the electrical design. Now what BMS does? The main function of a BMS, to maintain cell pack operational limits. So if I'm saying that my cell can work only between 10 degree to 60 degrees centigrade, and if temperature is rising to 65 degrees centigrade, so it should cut off the battery pack at 60 degrees centigrade. Obviously, it should give you some trigger at 55 or 50 that your temperature is rising, either you slow down or park at the side. But after 60 degrees, it should absolutely cut the battery pack. It's not only temperature. It could be current, it could be voltage, because all the things, if below some voltage, the battery pack will not work. Over some voltage, battery pack will not work. Over some voltage, that becomes overcharged. And then below some voltage, it becomes undercharged. Now, anything which triggers a safety concerning event, before it triggers a safety concerning event, the battery should be cut off. Who will cut off? It's a BMS which cuts off. Now, if there is a thermal management system, that should be controlled by BMS to maintain the particular temperature. And the communication and diagnostic, it should be able to communicate with motor, it should be able to communicate with other system of the vehicle. It should continuously monitor the energy consumption or incoming energy or outgoing energy, and should tell either driver or owner that this is what is happening, this much range is only available now, you need to charge. And if there are any faults, it should register those faults and tell us when this vehicle is supposed to go to maintenance, or this particular system is not working. Please check. Such type of thing. So it's a basically brain of the battery, which does all the things for a battery pack. Now, stages of battery pack further. How does a battery pack is being made? So the first one is cell configuration, series and parallel. We say MPNS theory, M parallel and series. A parallel gives you the capacity or ampere hour increase. A series will give you the voltage. If a particular cell is at if a cell, the nominal voltage is 3.65 and you wanted to make a 22 volt system or 48 volt system, sorry, 22 volt system or 48 volt system or 60 volt system, to divide this 3.6, if it is 60 volt, then 60 by 3.6, it would come approximately 16. So that would go in series. Now, if I want 30 Ah battery and I have a cell which can give us 6 Ah or 10 Ah or 14 Ah, to divide the Ah by the cell Ah and club together that many cells be in parallel. So that is what is series and parallel configuration. So that we say MPNS theory. I'll explain slightly better later on. Then structure. So that what definition we have made, mechanical, electrical and thermal there. BMS is already an independent part. So in structure, the case covers end plates, tie rods, cell holders, base plate. This all part of a structures, mechanical structures. However, bus bar, wiring, harness, fuse and plugs, these all are a parts. You can say mechanical parts, but belong to the electrical family. So should be considered during the electrical design. Then in the thermal, the cooling jacket, safety valves, thermistors, these all are structure, has to be taken care during the thermal design. The safety. On the mechanical side, we have to look upon vibration, shock abuse, crash, etc. However, in electrical side, short circuits and overcharge and over discharge. On thermal side, thermal runaway and thermal management. The control. What are the things we need to control? Any mechanical advantage, disadvantages like vibration, hardware robustness. On the BMS side, cell monitoring and BMS. And application. Application, interface and telemetry. Interface means interface within the system, within the battery pack. Between one module to other module. A battery pack can consist of several modules. The communication between every module. The connection between every module. And then outside the battery pack, like motor and controller, DC vehicle control unit, regenerative braking, ECU. So all those things would be considered under interface. The telemetry would come on the dashboard and can be connected with the owner or driver or a server, which gives the continuous information about range, any safety events, any problem, diagnostic, all those things. So let's move ahead. I'm showing you here a battery pack, the major component of a battery pack. What you see is here cells kept in series and parallel combination. The next one is the insulation pad. So the two cells should not come in contact together, especially when it is in series, to prevent the current leakage. We need to provide the insulation pad. This is electrical insulation pad. However, the problem with electrical insulation pad is it also becomes most of the time thermal insulation pad. So these cells cannot release the heat to other cells. Then base plate. The base plate is important for the holding all the cells together. Base plate, side strip and the end plates are responsible for holding all the cells together. Then cold plate is required for thermal management, keeping the battery temperature together. Keeping the battery temperature within the limit. Then bus bar holder. Now this cell has to be connected through bus bar, and then bus bar has to be placed somewhere. So this is the bus bar holder over which we can place the bus bar and can weld or screw this bus bar to connect the cells in series and parallel combination. Then bus bar. Then we need to monitor the temperature and voltage of the pack as well as cells, so thermistors and voltage sensors. Then wiring harness for efficient power delivery. So this wire has to be connected with a connector to the motor or to a junction box. Then the BMS. And then all these things should be covered by an outer casing, so that there should not be any ingress of dust, humidity, water, or anything which can harm the battery pack. So this was the introduction about battery pack. Now I'll move on mechanical design. Is there any question till now? Shall I go ahead?
Please,
Yes,
sir. Go ahead,
yes,
sir.
So what are the important considerations for a mechanical design? The first one is material selection. then base plate design for individual cells accommodation, then cell movement constraint and control, uniform pressure over cell surfaces, material cost optimization, hotel case design for overall protection, bus bar design. Even though it is not exactly part of mechanical design, however, this is what is going to deliver your efficient power. So most of the time it comes in all three topics: electrical design, thermal design, as well as in mechanical design. Then packaging constraints. By the packaging constraints, so I'll go one by one in subsequent slides wherever is possible. The packaging constraints, why it becomes important. This is what we were discussing. My vehicle may not have a uniform rectangular volume. It may have somewhere like this, somewhere like this, somewhere like this. So accordingly, I have to arrange my cells in such a way that it can utilize the maximum constraints related to the packaging. So within that particular space, we need to arrange our cell. And in fact, cell is also selected based upon the packaging constraints. There are varieties of cells available, which is available in the market. But OEM chooses a particular cells depending upon this packaging constraint also. It's one of the factor, not the only factor. It's one of the factor. So how do you make up a battery pack? First, you have to connect the cells together. So here I have taken an example of one of the prismatic lithium ion cell where the voltage is 3.65, current 15 ampere hour, length 17 mm, breadth and height, all the things has been given. Now, what I discussed there is MPNS theory. So if I'm going to make a 8P1S, MPNS, so 8 is M, 1 is N. So 8P1S, what does it mean? So 8 cells are in parallel. So what would be the voltage? The voltage would be 3.65 because all cells are in parallel. But what would be the current capacity? Since 8 cells are in parallel, so each cell is 15 Ah, so it becomes 120 Ah. So what would be the energy? So 120 into 3.65 is the energy. Now, look upon the next scenario. 1 parallel and 8 series. What is the current here? Current capacity. It would be 15 Ah. But what is the voltage now? 29.2 volt because 3.65 into 8. Energy? Energy remains same in the 8P1S or 1P8S. There it becomes 120 into 3.65. Here it becomes 29.2 into 3.65. Sorry, 29.2 into 15. So both become the same. So energy, even though energy is same, it's also what is important to know what is the voltage requirement and the current requirement. And depending upon that, we provide parallel and series connectors. Let's take an example here. Consider two-wheeler designed to have a range of 75 kilometers, which consumes 16.5 watt-hour per kilometer. That means in 1 kilometer, it will consume around 16.5 watt-hour on an average. The depth of discharge is 80%. Design a battery pack of nominal operating voltage 60 volt. What does mean depth of discharge? So I'll not charge the battery ever fully. I'll not discharge the battery ever fully. That is what is known as. That means I'll charge maximum 80%. I'll discharge maximum 80%. That is what is known as depth of discharge. Why we don't put 100%? The reason behind is that it increases the cell life, pack life. Now, what it is saying, power consumed by auxiliary system is 2 watt-hour per kilometer. So that means the total energy is being consumed 16.5 plus 2, 18.5 watt-hour per kilometer. So how do we find out the cell series and parallel configuration? So from that, what we can find out that 16.5 into 75 would become our capacity of the battery divided by 0.8 would become our battery capacity. Am I right? 75 into 18.5 divided by 0.8 watt hour should be the capacity of the battery. Now, what is the voltage? 60 volt. If I divide 60 by 3.65, it comes approximately 16. So how many cells we need to keep in series? So 16 series. How many cells we need to keep in parallel? To divide this total energy, whatever we have got from 18.5 into 75 divided by 0.8, that is the energy, and then further divide by 60, it will come 2. So 2 numbers of cells it will come around 30 Ah. So what cell we have? We have 15 Ah cells. So how many cells we need to put in parallel? 2 numbers. We have to put 2 numbers of cells in the parallel. So what would be the battery configuration then? The battery configuration becomes 2 parallel and 16 series. Now, if there is a space, I can make it as a 1 row or I can make it as a 2 row. If I make it as a 2 row, what would be the thing? How can we make? So 2 parallel 8S of 2 modules will make. And then we'll make these modules into series. Because 2 parallel is already there, 8S is in series, then another 8S is in series here. And this I can series like this. So my both negative terminal and positive terminal will come out from one side. Now, so how many cells total? Total cells are 32 cells here. 2p16s. 16 in series, 2 in parallel. 2 parallel, 16 in series. So the total number of cells becomes 32. And number of rows are 2. The number of cells in one row, in this one row, is 16. Another row is 16. The total cells of the battery pack, total weight of this cells of the battery pack. Now you see the previous slide, what is the weight of one of the cells? We have not given here. Okay. It's 0.32 kg. One cell weight 0.32 kg. So the total weight of the battery pack becomes, cells of the battery pack become 10.24 kg. Now, this 10.24 kg has to be taken care by the base plate. This weight has to be taken care by the base plate. You can see here, this is the base plate here. How do we calculate what should be the base plate dimension? We provide 1 or 2 mm tolerance on all the sides. And these dimensions also we have got from the length, breadth, and height of the cells. And then we provide some tolerances. And what we have found, it's supposed to be 272 mm long, 133 mm in width, and 124.8 mm in height. So what is my base plate? 274 mm by 134.8 mm. That had to be there. So continuous rectangular plate, constant thickness, simply supported on all the edges, uniformly distributed weight of the battery pack. Now once we have a boundary condition, we have a weight. We can use the design data book by calculating the area, load. We can use the design data book to find out what's supposed to be the thickness of the plate. But before going to the thickness of the plate, what is required is which material we should use. So the next, what we are going to talk is a very nice methodology, S-way methodology, and that is for material selection criteria. So what are the factors of the important? We want lightweight and the cheapest material with the highest possible strength. So highest possible strength becomes E, Young's modulus of elasticity. What we want? The weight should be minimum. So the density comes in 1 by, sorry, it, if the function is maximized, then rho would be minimized. The cost has to be minimum. So that's why it has come in denominator. The cost has to be minimum, the weight has to be minimum, and weight is dependent on the density. So this has to be minimum. So that's why it has come in denominator. However, my strength of the material has to be maximum. So it's in numerator. And what is the function? Maximize. If I maximize this function, automatically my strength will get maximized, cost and density would get minimized. Now, what we have to find out from a material library is what are the materials are suitable for this. So here we have selected two materials. ABS is also lightweight, plastic, aluminum is also lightweight, however metal. However, aluminum is metal will have much more strength. So these two material we have taken here, and out of these two material, it could be multiple material. You can put many more material, and then you find out the material index. Once you have found out the material index, what are the things we are getting here? This is 14.14 into 10 to the power minus 3, and what is there? Maximize. And what is here? With the case of aluminum, 5.17 into 10 to the power minus 3. Which material I'll select if there is these three criteria I'm looking for? If I'm looking for strength, cost, and weight. If this is the three criteria, if I'm looking for which material, and I'm maximizing this function. So which one is maximum here? ABS is maximum here. So even though aluminum has much more strength or Young's modulus, I'd say, but still I choose ABS because the cost and the weight also are also playing a very important factor here. And with that, the ABS has come a better material than the aluminum if these three parameters has to be satisfied. Now, once we have a material index done, then we have selected a material. For that material, till this time, we don't need to know what would be the yield strength or Poisson's ratio, the minimum, the first Young's modulus of plasticity. That is commonly known property. Density, cost would be available in the market. Then, to further analyze what would be the what thickness would be required, we need to know this yield strength, Poisson's ratios, and all the things. Now, do I need to do all the derivation of fundamentals of the equations? No. We'll use a design data book. From that, we'll put this all aspect ratio, Poisson's ratio, and all the things. And then we'll find out what would be the thickness. Now, the thickness has come 5 mm. Or if I allow the base plate to deflect by 1 mm. But sometimes I can allow it to 2 mm or 3 mm. It's a design, it's an engineering decision. If that is not going to impact my cell holder or bus bar, if that can take a deflection of 2 mm, then I'll go for 2 mm. My thickness would be reduced maybe 1 mm. So we have to decide what is the thickness, what is the deflection we can allow. That has to be known beforehand. And then from that we get a thickness of the plate. So if I use 4 mm thick, then what will happen? This would be around 1.3 mm deflection it can go. If I'm using 5 mm, then what is the deflection? 0.7 mm. If 0.7 mm is agreeable, I'll go for 5 mm. If 1.3 mm is agreeable, then I'll go for 4 mm thickness. Now, the similar way, what we have to do is to find out the side strip and the end plate. So what are the forces acting on the battery pack basically? Tension force on side strips, bending force on end strips, and then bending force on base plate. Shear force on welded joints, bus bar. Now, after saying that, what are the forces? So what are the five fundamentals of force, five fundamental type of loading? Compression, tension, shear, torsion, bending. And from that, we know stress and strain. I'm not going to further discuss on this stress and strain because as a engineering faculty members, we should understand this stress and strain. So, what are the things we have to do here? That bending force we have to put on the end, based upon this bending force on the end plate, and from where this bending force comes. So these all the cells required to be within some particular pressure, and that pressure values come from generally from the cell manufacturer. Once we know the pressure values, so we'll know this tension force. Once we know this tension force, we'll know what are the forces coming on the end plates. And then through design data book, there is a for mechanical students must be knowing that one, or the mechanical background people must be knowing that one. Mechanical faculties also they use extensively this design data book. What we have found Rook's design data book, that's a very good thing here. So after calculating all those forces together, then going through all the things, what we require is to do is the vibration analysis. What we have done there is that we have taken a static load of the cells together, and through that we have found out some thickness, some length, some weight of the plate. And what are the things we need to do there? Is the base plate, then side strips which hold the cells together, and the end plates which provide the sufficient pressure on the cell so that cell should not bulge out. The major reason for that is the cell should not bulge out. As soon as cell is bulge out, it will give you very less cycle life. So those all were the static loads. Now, the battery packs are not only subjected to the static loads, it's also subjected to the dynamic loads. And that dynamic loads comes as a form of vibration. So what are the types of vibration? That's the non-deterministic and deterministic. And deterministic, we have transient, harmonic, spectral, and the non-deterministic, random. So these all types of vibration analysis we're supposed to do for the certification purpose. And how does that certification has evolved? Based upon the road condition, the vehicle drive profiles, and all those things. So in that, this random and harmonic vibrations are generally vibration analysis method. And then when we say transient and spectrum, these are shock analysis methods. Now, the specific requirement for L category electric powertrain vehicles is AIS 156. L category means it's a two-wheeler and three-wheeler mostly. For harmonic vibration test, what we have to do? AIS 048. Shock abuse, again AIS 048. Random vibration, SAE J2380. So if you say AIS 156, what are the requirements? For a specific requirement: vibration test, thermal shocks and cycling, mechanical drop tests, mechanical shock, fire resistance, and specifically for electricals, short circuit, overcharge, over discharge, over temperature withstand voltage, and water resistance. For all the above tests, AIS 156 has a nice definition. It's a free. You can download from ARI website, and you'll understand what are the things are. What are the tests required there? And this is why this test has been done to standardize. Okay, this battery a battery pack made by manufacturer A or made by manufacturer B or made by manufacturer C would certainly withstand all this road condition for these many cycles. That in other word we say homologation. So we homogenize all the types of battery for a certain standard, some certain particular number of cycles, particular number of kilometers, particular number of capacity. Now, how do we do all this vibration test? So there would be a standard equipment, jigs and fixture. Over that we pack, and then we vibrate in X, Y, and Z direction. And how do we do? You can see here. Like if we have a small duties, the small object like BMS of part, and then if you are going to do it as a complete pack is in the bottom. Packs. There are different types of vibration machine. This can go for X direction, and sorry, here arrows are wrong, so don't take it as it has been rotated in such a way that here the object itself has been rotated. Here you cannot rotate the object, so because it's a very big. Now, the duty has to be fixed on the platform properly, and then there will be a vibration shaker that will give the vibration based upon either on the road profiles or some sinusoidal waves, predetermined sinusoidal waves, and accordingly, it would be checked that how many failures and where are the failures has happened. Does the battery pack lost any energy? Does it triggered any critical events? So all those things would be checked there. So these are the test standards in that what it is saying in AS048, sinusoidal waveform with a logarithmic sweep between 30 Hz to 150 Hz and back to 7 Hz at 3G acceleration. Then this cycle has to be repeated 12 times for a total 3 hours for each of the 3 mutually perpendicular mounting position, X, Y, and Z. And shock abuse, 10 shocks in each axis in half sine wave with 30 G. The G is acceleration due to gravity, and the duration of that would be 15 milliseconds. So one of how these tests are being done. So that's the video. Can you see the video?
Yes, sir. Yes, sir.
So this is shock test. It's lifted up, and from there it's just free fall. It's coming up. So what are the criteria for those type of steps? Generally, no mass loss. That means there is nothing, no leakage has happened from that. No leakage or venting. That cell has not ruptured. There is no gas formed, so no venting. No disassembly. It has not. It is still in integrated form. No rupture. The cell has not cracked. No fire. And then open circuit voltage is greater than 90%. That means cell has also not lost its capacity. And the rated capacity, the deterioration should not be more than 10%. So these are the past criteria. So with this, I'm summarizing mechanical design. So mechanical design of battery pack lead to a safe and cost-effective structural element that has to be lightweight and highly reliable. Various factors: material selection, S-wave method, loading condition on base plate, end plate, and side strip, which we have not covered. It takes quite long time. So I just have given you that's how you can do that. Bus bar and outer casing development that we have to take care. Base plate, free base plates and end plates, free and forced vibration, and the methodology of various testing. So now the 15 minutes is left for the question and answers.
Thank you, sir. Participants, please post your questions in the chat box, or you can directly talk to the resource person. Sir, we have one question in the chat box.
Just
I
a
will
minute.
read out the question, and if we can see that the
Yeah.
fire ignition in a fully charged battery pack in case of electric vehicle meeting an accident can be tremendously explosive. In this regard, what constructional and materialistic features can be adopted to avoid the impact into the electric vehicle cabin or to break the cabin or ignition within the battery cells? Question from Matsudan B. Mite.
I know. The first of all, as soon as we are talking about the crash or something like so, such type of situation only this type of things can happen. So in that cases, at least what we need to do, we have to make a pack in such a way that it can try to absorb all the energy possible. However, that could lead to the over design of the battery pack. So can we have something there like phase change materials? Pack itself would be made of a material with that high, in the case of accident, could have a power of absorbing the energy of explosion of the cells by changing its phase from solid to liquid. So still it can be prevented. So you can mitigate the accident towards cabin. And certainly you cannot allow this fire should go inside the cabin. So at the top surface, if you are putting it at the bottom, or if you are putting below the second row seat, so that place has to be secured properly. There's other ways also. Once you quickly cut off the battery pack through BMS, that's where BMS becomes very important. Then there is no in and out electricity going on, and it would be just a chemical energy, and that may not propagate to the extent which it could have if it would have been uh, in running condition. So, and obviously we need to provide the crash observers and all the things, but generally that becomes more on the vehicle side, not on battery pack. The vehicle should be rigid enough not to allow energy to be transmitted to the battery. Okay, the second question is how to compensate the material properties and electrical properties in case of vibration and other physical forces while designing the. So in the case of vibration, the electrical property changes only because of the contact resistance. The contact resistance may increase or decrease. So you have to use uh, uh, bus bar securing fasteners like a lock type which can get locked, should not slip, or could be welded either through spot welding or the laser welding. And then there has to be sufficient cushion. Also, cushion in the sense, again, that vibration should not, that complete road vibration should not reach directly to the battery pack, should be absorbed in between that also. By designing a proper suspension system. However, you must have to worry about the contact resistance. That should not change because of vibration. And why? Because of vibration, what will happen? Either it's a loose nut or loose connection. So that type of nut and bolt you need to use, which does not get impacted through the vibration for bus bar. That's the most important. Okay.
We have another question, sir.
Yeah, I am keep on reading that one.
Okay.
Anything can be done to break the chain of ignition from cell to cell inside a battery pack. We do a lot of things for that one. So phase change material is one of the things there. Then providing the insulation, what you have seen, that electrical insulation, that also helps in thermal insulation. If there is a thermal management system, then what happens? Sometime if it is active thermal management system, so sometime we provide a vent in a refrigerant line. So in case of temperature shooting beyond the control, so that's open up and then try to cool. So try to cool means it is absorbing the heat. So see, I'll tell you one thing very important here. If you don't allow the temperature to exceed to a particular number for that cell, it will not go in thermal runaway. And if it will not go in thermal runaway, then there is no chance of ignition from one cell to other cell. If one cell goes in thermal runaway, it's very difficult to control the whole module or the whole pack to go into thermal runaway. It's very difficult. However, there are methods being developed, like insulation materials, in such a way that it won't allow the temperature of one cell to reach to other cell. Some of them are there, not very great. People claim it's great, but not very great. But yes, it's a working well as of now. Yes, there are warning systems. So we provide thermistors, correct? We provide thermistors, we provide thermocouples, and temperature is being continuously monitored. Obviously, I cannot provide n number of thermistors. I have a limitation of providing the limited, means I can provide only limited number of thermistors or temperature sensor. But then we do lot of thermal modeling. So we know if this cell temperature is at that particular limit, then what would be the other cell temperatures? And based upon that, BMS will take a call to cut off. Okay, what design characteristics determine the current capacity in a battery? It's a basically cell. The cell has a particular current to be withdrawn and means to be charged and discharged. So generally cells are manufactured for 1C discharge and 0.5C charge. However, there are various cells which can give you up to 2C. If you understand C means if it is 15 AS cells, and if I'm taking out current 15 ampere in 1 hour, then it is a 1C discharge or charge. If I'm taking 30 ampere current, then it's a 2C discharge. If I'm putting back 30 ampere for a 15 AS cell. So that determines the current capacity. That's one. That's a very basic is one. The second one is the bus bar. If my bus bar is not designed properly, then it won't give you the required current. It will get heated up, it will melt up at the end of the day. So that is what is the current capacity in the battery, what the design characteristics. It's basically electrical design, bus bar and the wiring harness. Okay, Maharshi Subhas. Yeah, it's 988-4254-105. 988-4254-105. That's my contact number.
Okay, sir. Thank you very much. I think any more questions from the participant side?
You can ask even through your mic also. That's not the issue. We have still few minutes left.
Okay, sir. Okay, right.
You can ask anything from the AV if you don't want to ask question from the battery mechanical design. I think some of the students are also there. 4MT18 ME024. You can also ask MTech students, I think. Am I right?
UG students.
Yeah.
engineering students.
Yeah. So you can also ask. No need to be sorry. I finished session slightly early. The reason was I wanted to know more questions.
It is on time and a very informative session, sir. Ranjan Kamath, do you have any questions to Professor?
No, sir.
Mohan Kumar, please.
Yes, sir. So, if there are no questions, I think we can conclude this session.
And one more information, Mohan Kumar, same resource person, Dr. Kaushal Kumar Jha will be presenting tomorrow morning about the thermal design. Please highlight that. And those are interested in the student side, they also can participate tomorrow morning.
Okay, right. Yeah. So before concluding, as our coordinator, Dr. Rajshekar sir informed, tomorrow morning first session will be handled by the same resource person, Dr. Kaushal Kumar Jha, about the thermal design of the battery packs. So those who are interested, I mean, apart from the participants, the students, those who are interested, can definitely participate and gain good amount of knowledge. So
Thermal would be much more interesting than this session because I'll tell you my expertise is thermal. So anything in thermal, you could ask, think, and I would be able to answer.
yes, sure, sir, sure. So participants can make use of it to the maximum extent, his expertise. So current session was very informative and very interesting and very interactive also. The kind of interaction from the participants, response from the participants showed that the professor has done a very good presentation and very informative session. So in fact, he has given a very detailed information about the mechanical design of the battery packs and also with some numerical analysis. He has explained very beautifully. So it was really a marvelous session. So thank you, sir.
Professor Mohan, just a minute. I have a question. Can we use inverters, batteries for car? Okay.
Okay.
See, you understand why we use inverter? So inverter we use if there is emergency power down and for 3-4 hours, 5 hours. So generally inverter people uses the places where the power is away for 4 to 6 hours. Otherwise, generally no. So in that cases, the discharge capacity. So the battery would be such a way that your discharge can happen in 2 to 4 hours time. That means if you convert into C rate, it would be something between 0.5 C to 0.25 C. For 2 hours, it would be 0.5 C, and for 4 hours, it would be 0.25 C. However, in cars, your discharge can go up to 2C, 2.5 C, especially where you have a gradient, like you're going on hilly areas or you're going over flyover. In such cases, your discharge can go up to 2.5 C momentarily for few seconds, 10 seconds, 20 seconds, 30 seconds. So in such cases, the inverter batteries you cannot use directly for the EV application. The principle remains overall same only, but then the cell changes, the control methodology changes completely. On the mechanical design, that's a static application. You don't have to worry about vibration and other thing. However, for a movable application like EV, you have to worry a lot about vibration, dynamic loads, and all those things. So yes, even though the EV cells can be used for inverters, inverter cells cannot be used for EV, and the design philosophy would be entirely different. Their weight, dynamic loading is not a problem. Here, your weight as well as dynamic loading is a problem, as well as charge and discharge rate. Yeah, you can go ahead, Mohan sir.
Yes, sir. Thank you very much, sir. So with this, let us conclude the session. So on behalf of the management and the Department of Mechanical Engineering, I would like to express my heartfelt gratitude to Dr. Kaushal Kumar Jha for having accepted our invitation and presenting the lecture. And also tomorrow also he will be joining us to enlighten our knowledge. So thank you very much, sir.
Thank you, sir. Thank you very much.
So I thank all the participants for actively participating in this session and making the session a successful one. So thank you. So thanks are due to all the students who have participated here. Okay, so thank you everyone. The attendance link for the participants is posted in the chat box. You can mark your attendance. So thank you very much. Thank you everyone.
Thank you.
So let us join tomorrow morning for the session by Dr. Kaushal Kumar Jha in time and grab the knowledge. Okay. Thank you. Thank you everyone.